like a period is essentially like the distance between repeating points. For example, look at this point here. This is the point where like the graph turns like this, ne? Turns like this, ne? The point where the graph turns like that. It's like a maximum point, like the maximum point of the graph, maximum turning point. I get. So where next is our maximum turning point is here. The graph turns again here. Now you're gonna look at this point and that point where it repeats. You're gonna find this distance. This distance is what we call the period, and it is measured in terms of x values. So the distance from there to there is just the distance from 0 degrees to 360 degrees. So that is 360 degrees. That's the period. Hence, this 360 degrees we found there. Do you guys see what a period is? You can also do it mathematically. You can just go the 360 minus 0 degrees gives you 360. That's your period. Let us look at another like sort of point that repeats. You can look at this point. It's essentially turning the minimum turning point, ne? Lower turning point. It repeats there, ne? So now you're gonna find this distance from there to there. So this is 180, this is 180, so it's gonna be 180 from there to there, 180 from there to there, which gives you 360. You guys still see that the period is still the same, it does not change. A mathematical way of doing it, you can just say the bigger number, 180 degrees minus the smaller number. The smaller number is minus 180, which gives you 180 plus 180 gives you 360 degrees. Sisonke madoda. Mholi, are we good? Letabo, are we happy? Tepang, do you trust the process? Proper stuff, proper stuff, proper stuff. Kanyo? Shalom? Alright, alright, alright. Alright, Matiotia. Sharp, sharp. So that's how you get the period. Another way in which we could look at the period. Let's use this point. I want you guys to see it. Let's look at this point, this one. It's basically where the graph is going from being above the x-axis to being below. It crosses there. So the same point is where, not here. Here it comes from below and then it crosses, goes above. So we're looking for this point. It repeats there. Yeah, it's a point where the graph comes from above, crosses, goes below. So this distance, this is 90. The x is 90 there. X is 270. You're going to go 90 minus 270 because this value is minus 270. This gives you 90 plus 270, which is just 360. The period is still the same. So how to calculate period? You look at you follow that sort of procedure using the graph. If they don't give you the graph and just give you the function, you use this formula. This formula applies for cos and sine. Yeah? Cos and sine. The period of cos sine as well is this 360 minus divided by the number in front of cos. However, the period for a tan function, tan, is period equals 180 degrees over b, the number in front of x. The difference is that for the tan we have 180, for the cos and sine we have 360. Please do not forget that. Sharp. So now that I have basically shown you the basics, I think we should start doing past questions now. One more thing before we do past questions. One more thing, translation. I need to teach you quickly translation. Translation is movement. Let's use an example. Movement. Okay, we still have the graph of cos x in front of us. So now we have the graph of cos x. We want to draw the graph of cos x plus 1. Okay, fine. Now, what did I do to the graph of cos x to get cos x plus 1? They shifted the graph of cos x 1 unit up. This plus 1 means 1 unit up. If it was 2, it would be shifting the graph of cos x 2 units up. Are we together? So if it was negative 1, it will mean that we are shifting the graph of cos x 1 unit down. If it's negative 3, it means that we're shifting the graph of cos x 3 units down. So let us focus on cos x plus 1. Sharp. So it's a shift 1 unit up. a shift 1 unit up. Okay, so how do we sort of draw it on the diagram? Every point must be shifted 1 unit up. Just focus on the key points. Okay, so this here's the first key point. It gets moved 1 unit up, it's gonna be there. This point here, 1 unit up, it's gonna be there. This point here, 1 unit up, it's gonna be there. This point here, 1 unit up, be there. This point, there. You move this point 1 unit up, there. This point, 1 unit up, there. This, there. This point, there. Your new graph will be like so. Okay, this will be the graph of cos x plus 1. Do you guys see the importance of knowing how the graph of cos x looks like, sin x looks like? Once you know them, everything else is just a transformation. So you may not even need your calculator when you're asked to draw the graphs like a trig graphs. Very, very easy. Are we all together? The whole class? That's nice. That is proper stuff. Okay, sharp. So now, so yeah, as I said, if we go -2, if we put -2 here, it means that we're shifting 2 units down. You just basically do the same as I did just now. Now let us explore. So this is a vertical movement, moving up or down. What about moving sideways? So if I'm asked to draw y equals cos x minus 19, okay. Now I'm gonna delete this one, the red one, quickly, so that we have space. Sharp. So let's delete these points as well. Yeah. So now they ask us to draw this. Now what is this? This is a horizontal shift, moving sideways. When you have a minus, what you expect is for something to move towards the minus side of the x-axis, but that takes the opposite. It's just how it is. It takes the opposite. So instead of this being a shift 90 degrees to the left, it is a shift 90 degrees, shift 90 degrees to the right. If it was like so, this is a shift of cos x. If it was so, cos x plus 90, it would be a shift 90 degrees to the left. Because it's positive, it sort of opposes the sign. So let us draw this function of the function cos x minus 90 degrees. So every point just gets shifted 90 degrees to the right, since it's negative b. So we start with this point here. This is the distance. Okay, let's start here. Let's start with this point is at 0. Shifted 90 degrees to the right, it's going to be there. I start with this, I follow that with this point. It's going to be there, 90 degrees to the right. This point, 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 90 degrees there. This point, 90 degrees. That, 90 degrees. So your graph will look like so. You see? So this will be the graph of cos x minus 90 degrees. If it was positive, we would have moved positive 90, would have moved each point 90 degrees to the left. If it was 30 plus 30, we would have moved every point 30 degrees to the left. Are we all together, good people? Yes? Yes.